Good morning, guys. We are getting ready to do our lesson. Let me get it on here. Alrighty. It's on gravity and graphs. Let me move my people out of the way so we can see. Oh, it's making me log in too, Miss Sparks. No, let's make it. Can you see my screen? Okay. I don't know why. All right, there we go. Gravity and graphs. Sorry, guys. All right, we are going to read a book, Gravity, Do You Feel It? It's by Buffy Silverman, and I got this book from Epic, so you can log into Epic using either mine or Mrs. Sparks' class code to go back before you take your AR test. It's worth 0.5 points. And here we go. Gravity, do you feel it? Says, what is gravity? Toss a ball into the sky. No matter how hard you throw it, the ball comes back to the ground. What makes the ball return to Earth? Gravity. Gravity is a force. A force is something that pushes or pulls an object. The Earth's gravity pulls objects towards the center of the Earth. What would happen if there was no gravity? Rocks, houses, plants, and animals would float into space. People would float too. The force of gravity pulls all objects towards each other. Every object in the universe pulls on every other object. The Earth, Sun, Moon, and planets pull on each other. Buildings, cars, and trains pull on each other. You have gravitational pull too. How does gravity work? Well, everything in the universe is made of matter. People, air, water, rocks, and planets are made of matter. Scientists call the amount of matter in an object its mass. Objects with more mass have more gravitational pull. The Earth has much more mass than you do. That means that the Earth pulls with more force. Your weight is a measure of the pull of gravity between you and the Earth. The Moon is smaller than Earth and has less mass. That means that its gravity has less pull. So a 70-pound, which is 32 kilograms, child weighs only 12 pounds, which is 5 kilograms, on the Moon. So if you're 70 pounds here, you would only weigh 12 pounds on the Moon. That's pretty cool. It keeps looking like it's skipping pages for some reason.
Yeah.
Orbiting in space. Objects in space pull each other together. The sun has much more mass than the Earth. Its gravity is stronger. The sun has a greater pull than Earth. It holds the Earth in place as the Earth moves in an orbit around the sun. The Earth has more mass than the Moon. Its gravity is stronger. The Earth's gravity pulls more than the Moon's gravity. The Moon orbits the Earth. It cannot escape Earth's gravity. The force of gravity also depends on the distance between two objects. Planets that are far apart have less pull on each other. Imagine traveling far from any moons, planets, or stars. There would be almost no gravity pulling on you. Then you could float away. Alrighty.
Sorry.
Guys, there's a glossary in the very back of the book for your new vocabulary words. So on your slides that you're going to see, you're going to need to have those, okay? So review questions. What is gravity? The book told you what is gravity, so if you don't remember, pull up Epic and go to that book and you'll find the answer. Question 2 says, how does gravity affect people on Earth? In the book, it'll tell you that, okay? The next two questions are about you. Would you like to travel to space? Why or why not? And answer those questions. What do you think it would feel like to be in no gravity? And then write what you think it would feel like. Okay, we're going to go to the next slide. Okay, the next slide, I want you to define these 4 vocabulary words. And remember, they are located in the glossary of the book. It's a gravitational pull, force, mass, and matter. Now, guys, mass and matter, we spent a lot of time in science class, so you should know those. But if you need to review, they're in the glossary, okay? All right, Mrs. Sparks is going to do a lesson now on graphs.
All right, guys, there's different types of graphs, and we haven't touched a lot on those in math class, but I know Ms. Bramer has a little bit in science. So there are several types of graphs that scientists and mathematicians use to analyze different sets of data and numbers. So this graph on this slide is a bar graph. And bar graphs are often used to compare values. So if you look, this graph is showing the distance of each planet from the sun. So if you look, Mercury, let me move my people over. Mercury is a smaller distance because it's not even from 0 to 500, but Neptune is all the way up close to 4,500. So this is a bar graph. Okay.
Sorry.
It's okay. These are pie graphs, and these help us remember. We've done some of these similar in math when we do fractions because they kind of look like pizzas, and we can break them apart in half or in fourths. But pie graphs are often used to compare percentages or parts of a whole. And remember, parts of a whole are like fractions, okay? So these are different percentages for, this is atoms and dark matter and dark energy. And this is 13.7 billion years ago. So these are pie graphs, and you can easily remember that because it's like a pizza pie. All right, and this is a line graph. It says line graphs are often used to show rates of change. So if you see right here, the bottom part, or the x-axis, is time. And the more time goes up, the higher the speed is, because see over here on the y-axis, that's the speed. So line graph shows rates of change. And it says, when you're planning to graph data, you need to answer some questions before you begin. So before you know what kind of graph you want to use, you need to be able to go through all these questions. So it says, what type of graph will you use? What unit of measurement will you use? What scale will you use? What will be the minimum and maximum values on your graph? So like 0 to 100 or 0 to 10. And then will your graph start at 0? Maybe your graph needs to start at 20 so you can show more growth between like 20 to 1,000 or something. So not every graph needs to start at 0. For bar and line graphs, every graph needs a title and labels on the horizontal, which is the x-axis. It's the side to side, the bottom. And the vertical, which is the y-axis, which is the up and down. And we've talked about that with the coordinate planes. So the unit of measurement you're using needs to be clearly shown. So like, for example, inches, kilograms, centimeters, etc. You also must choose a scale for your vertical y-axis. The scale is determined by the data you are graphing. To determine the scale, look at the largest and smallest numbers you'll be graphing. Like I said earlier, you don't necessarily have to start at 0 if all of your numbers end up from like 20 to 100. So you don't have to start at 0. You could start at 20 if you need to. This is how to make a pie graph, and this is the line graph. This says the scale is determined by the data you're graphing. To determine the scale, look at the largest and smallest numbers. So I cannot see those numbers right there. Let me put on my glasses. Maybe that'll help. Nope.
60, 65, 70. It goes up in by fives.
Okay, so see right here, this is what I was talking about when I said the graph doesn't have to start at 0. This one starts at 60 and goes up to 95. And on the bottom, if you look at the bottom, these aren't numbers. They're actually months of the year. So your graph can have numbers or different topics like months or days or whatever your graph is going to be about. The bottom mentions a pie graph. A pie graph is shown using a circle, which is 360 degrees. And it says you start by making a circle. You'll then multiply your fractions or percents by 360 degrees. It gave you a chart on the side. And this one is about colors. So there's blue, green, red, pink, and then the total. So all of those numbers, all those percentages right there have to equal 100 or your pie graph will not be correct. Okay? All right, so here's some questions. It says graphing distances in the solar system. You're planning to graph distances from the planets to the sun. Plan your graph by answering the questions below. Now, you'll use the next slide to help you answer these questions. This is the slide right here that you'll use. So it says, it's okay. So you'll just refer back to this slide as you answer the questions on the previous slide. Okay, so the questions are, what type of graph will you use? What unit of measurement will you use? What scale will you use? So what number to what number, like 0 to 10 or 20 to 100, in increments of how many? So are you going to go up from like by 2s, by 5s, by 10s? What will be the maximum and minimum data values in your graph? So how big and how little? And then will your graph start at 0? If not, with what will your graph begin? And that'll help, number 3 will help you answer that as well. Okay? All right.
Okay.
We want you to complete all of your work before the next Zoom meeting. I'm going to let Miss Bramer take over.
I'm sorry, Miss Sparks.
It's okay.
Guys, don't forget to complete your AR test. By answering the questions I gave you, that will help you with your AR test. Okay, so don't forget to log in and do that. Make sure you're getting your iReady minutes, 20 minutes per day in both math and reading. That will help you keep the skills that you already have, guys. We don't want you to lose anything. So make sure you're doing that. You have lessons on Science A to Z. It's good if you can do one lesson per day. And I'll get in and check and see how your progress is and take the quizzes. Most importantly, read, and read some more. Make sure you're reading, guys. Reading is the most important, okay? Ms. Parks, did you have anything to add?
Yes, we will go in Wednesday morning and check for who all has done their AR test and their iReady and their Science A to Z, and then we'll do our shout outs every Wednesday.
Yep. All right, guys, we will see you. Remember, our meeting days on Zoom are Wednesday, Thursday, Friday at 9 a.m. every day. That'll be the same every week, okay?
All right.